By the end of this lesson, you should be able to explain buoyant force, relate buoyant force to the weight of the liquid displaced. When an apple is dropped into the water, it does not sink. Why? What happens to the apple? The apple floats. What happens if we press the apple down into the water and then release it? When the applied force acting on the apple is released, it goes up. This shows that there is an upward force acting on it. It is called the buoyant force. What are the forces acting on the floating apple? What can you say about them? The forces acting on the apple are its weight acting downwards and buoyant force acting upwards. When the apple is floating in water, these forces are in equilibrium. The resultant force is zero. That is, the buoyant force is equal to the weight of the floating apple. Observe the water level. What happens to the water level when the apple is put into the water? The water level increases. Why? When the apple is put into the water, the volume of water displaced is equal to the volume of apple that is submerged in water. Let's carry out an activity to study the relationship between the weight of the floating apple and the weight of water displaced. What is the mass of the apple? What is the weight of the apple? Click on the apple and place it on the weighing scale. The mass of the apple is 200 grams. Therefore, the weight of the apple is 2 newtons. What is the mass of the water displaced? What is the weight of the water displaced? Click on the apple and place it in the water. The mass of the water displaced is 200 grams, and thus the weight of the water displaced is 2 newtons. What can we conclude from this observation? The volume of water displaced is equal to the volume of apple that is submerged in water. The weight of the water displaced is equal to the weight of the floating apple. We also know that for an apple to float, the buoyant force should be equal to the weight of the floating apple. Therefore, we can conclude that when an object is floating in water, the buoyant force is equal to the weight of the object and is also equal to the weight of the water displaced. Let's investigate the case where an object is totally immersed in water. What happens to the egg? The egg sinks. What makes the egg sink? What can you say about the weight of the egg and the buoyant force? What happens to the water level? The water level increases. Why? Let's carry out an activity to see the relationship between the weight of the egg and the weight of the water displaced. What is the mass of the egg? What is the weight of the egg? Click on the egg and place it on the weighing scale. The mass of the egg is 60 grams. The weight of the egg is 0.6 newtons. What is the mass of the water displaced? What is the weight of the water displaced? Click on the egg and place it in the water. Mass of the water displaced is 50 grams. The weight of the water displaced is 0.5 newtons. What can you deduce from this observation? The weight of the egg is bigger than the buoyant force. The resultant force acting on the egg equals to the weight of the egg minus buoyant force, equals to 0.1 newton. Since the resultant force is not zero and acts downwards, therefore, the egg sinks. We can conclude that when an object is totally immersed in a liquid, the weight of the object is greater than the buoyant force. In this case, the volume of the liquid displaced is equal to the volume of the object immersed in liquid.